There will be an input layer, some hidden layer, output layer, and the output. Basically, first you consider there is a set of input vector, there is a set of output vector or one output. So we are considering the initial one matrix, one characteristics matrix, which is producing the output. Now keep on recursively, we are changing it. What is the value of this matrix to get the best output? Once it is obtained, then I got trained. You see, when childhood we writing A, it was not that much good and fair. Slowly, when repeatedly you are doing, it has become perfect, like a print. It will come slowly. So you are repeatedly, how much you are getting trained, your response will be that much better. So how much it is coming, we are repeatedly, recursively rotating it to get the perfectness. So this is the basic structure. I'm not going in details how the neural network works because that is another subject. I am trying to explain you the application of that. And here, a lot of algorithms are used to train the network. So normally I am, so far whatever the work done, I have done through that Leeuwenberg-Marquardt algorithm. MATLAB also implemented that same. So you can, if you want to know that, you can read that in any standard book. Now I will show you few just MATLAB syntax. My computer may be very slow. So let us take one variable x1, which is going 0 to 200. I am taking one more x2, which is also going varying 0 to 200. Very simply. Now I am say there is one equation which is x1 square plus 3x2. This equation I don't know. So let us, for a system, these two are the input and y is the output. So from the time domain data, time domain measurement, I got x1, x2 and y. Now I have to estimate this. It's a nonlinear in behavior. It's a nonlinear equation. It's a quadratic equation, quadratic polynomials. Now, by analytical method, it will be quite difficult. Now, I'll try to apply the neural network. Just I am showing the syntax of that, so that you can do it by your own. And one thing I am telling you, I used to tell everybody, to my every students, that your technical knowledge should not be limited on in your paper, books and all. In my opinion, whatever we have learned, if we are not able to implement it for the common cause, for the improvement of the society, for the mankind, then there is no use. We may know so many things. Try to implement it. Try to implement it. Try to implement the things which you have learned. I always used to do that. Please try to do that. I know some of your seniors, some of the students, previous students of SSN college, now they started their own, they become entrepreneur. Very young age. They are influenced by that. And one more thing is very true. Rather than after completing the degree, rather than becoming a job seeker, all the people become a job seeker. this cannot, the employment, the need of employment cannot be catered if your mind is set, your mindset is like this. Rather than do so, you have to think that to become entrepreneur, it will much more feasible for the country with high population of high population volume. Try to implement it. It will give mental satisfaction. After doing electrical engineering, electronics, all these things, if you are not able to give a output of a converter, it's very pathetic. Even though if you have thousands of papers, this, that is, I don't think this that much worthy. So try to implement always. It will bridge between the academics and the your uh, physical output. Okay. So to do that, just there is a command called nn start. If you so this is the GUI, it will open. Okay. Now I am setting one input, which is x1. Everything I am representing as vector. Now I am this is it's a fitting app. So your input is x and your output is y. Yeah, it is a column matrix. You can change it. So first it is taking 141 based on the, it is automatically taking the length of the vector, and from there it is deciding. You can change it always for the validation, how many things you want. You can change it. Okay. So first it will train the network. That means by dynamically it will change the value of the each element of the matrix. Then it will test it, how much closer it is coming. Then number of neurons. If the number of neurons are more, that means your brain is more powerful. So here it may take time. So that's why I'm taking 10 neurons. How much you will increase, it will give that much better result. Now it is creating the network, and there are the algorithm. This is the Bayesian algorithm. This is the conjugate gradient, but I will use this. And now I am training the network. Now my network is ready. Now I am repeatedly telling, like my mother is telling me to write A 100 times. I'm writing, and storing that movement. I'm capturing it, the action of my hand in my brain. That work I am doing. You see, it is getting trained. I am in home, okay. Around 11:45, I will come to lab. You see, now it is getting trained. It got trained. The network is trained. Okay, you see now I got the network trend. So now if you given the name as net, so now if the value is 2, if the value is 2, what should come? 10, it should come 10. You see, it is coming like this 10.001. That is the error. So this is the simple, without understanding much more detail on the neural network. It's a part of learning, machine learning. Later on, if people are interested, I'll be happy to do all these things. Your TensorFlow, Python, how to implement all these things. That customized code also I will explain. That is a very good topic, and hope for next 30 years, 30 to 50 years, the entire industry will be dependent on that machine learning only. So this is the thing why I told to just give a overview. This is the model. This is the model which is used to predict the uh, predict the rotor flux. This is the rotor flux and the position theta. This is the model used. How this model came? If you see the governing equation, and from there you can easily make this block. So this, where it is coming in the vector control, this is coming from the that 3-phase to 2-phase transformation, the theta. Where you will get the theta, this theta will go to that block. So you will take 3-axis current. I'll show you the model also. So from the 3-axis current, it is converting this omega r, it is coming from the encoder, and these are the passive parameter. And this is the simple equation, that differential equation. This is star means integration. Okay. This is the very, very simple thing. So here, these 3 terms is adding, and basically this is equal to d psi rq by dt. You are integrating and you are getting psi rq. And this is the model. Whatever the things it is here, I have shown that things is in PSIM, it is modeled like this. It is some same thing. It is getting modeled. Here, it is line by line. It is, you see, this is the model. That whatever the current model you have seen just now, that is implemented first. So you take a machine and you implement it in a microcontroller. Then you capture in the neural network, because I need to find out this 1/tr. Okay. Then these are the parameters are taken as the input of the neural network. ID, IQ, and any phase current, because I am considering it's a balanced load. So all the phase currents peak will be, RMS will be equal, and RPM. From there, a table is generated. You see, this is the table. This is the data set. Because this is a part of, it's a part of big data analytics. Lot of data you have to process. Lots of data, unbiased data. So these are the output from the model. By changing the value of RR, arbitrarily this has been taken, and this is your phase current, ID, IQ, and your RPM. Now using this value, a network has been trained. They have trained one network and they got the perfectly, they have got the output. You see, this is error. This is, they have plotted the error. But this is in 10 in the order of 10 to the power minus 3. That's one. It is perfectly matched. But if you want to estimate this by any analytical method, because you know the transfer function is so complex, so difficult, you cannot decouple one from other. It is very, very difficult. So in such nonlinear case, where so many things are dynamics are coupled together, this neural network and machine learning, it will be a best option to get the actual things, actual parameter. It's a kind of model. You see here, no model needed. To estimate this, even though we are using some model, but to final estimate it, there is no transfer function. There is no predefined model. It's a kind of model-free adaptive control. So now, instead of a static system, I need to implement a additional machine learning hardware through which instantaneously it will estimate the inverse rotor time constant, and that will be fed through the inverse rotor time constant wherever needed in the vector control. So this is the concept. So in microcontroller, to implement it, what is needed? You need to understand how to configure the ADC, because your current will be captured through ADC. Then how to configure the timers, how to implement a digital controller in microcontroller, how to produce the PWM, and how to count the quadrature pulse, because your RPM, it will be given as a quadrature pulse. How it is to be counted. These are the things only needed to implement it. Rest of the things, it is readily available in the market, IGBT, everything. Hope it will be available in your lab also. You can implement it, whatever I have told you. Another simple way is that this TMS, all the Texas controller, that is all the Texas controller, this kind of controller. You see, all that this is TMS 320F 280 28027F. It's a very powerful controller. This is a DSP controller. If you want to implement rapidly, means for rapid prototyping, you can use this controller, and you can implement that things in Simulink, and it will be, the code will be generated. That code, it will be imported to Code Composer Studio, and you burn it without knowing any bit settings of the register. Very quickly you can prove the concept. In my YouTube channel, there will be some video related to this. All are there, whatever I told. If somebody interested, you can watch it and you can implement. And in case of any help required further, you can contact me. So this was all about today's session. I think time also over. So if anybody have any question, you can ask, or we can terminate it, this session.
So on behalf of the Department of EEE, I thank Mr. Bishwas for spending his valuable time in spite of his busy work schedule. So we thank you for delivering this lecture in the national seminar, sir. Thank you, sir. We hope to see you for our future workshops and conferences also.
Good. I am interested.
Thank you so much, sir, for your informative lecture. Thank you so much.
Thank you, madam. Thank you to organizing committee of this seminar to give me the opportunity to share my knowledge, and I'll be happy to do same in future also. Thank you so much.
Thank you, sir. Thank you.
Thank you so much, sir. So with all your permissions, I just end the meet. Thank you so much, sir.
Thank you.